Gilbert pioneered the study of magnetism in the 16th century. In his most important book on the subject, Gilbert elaborated an entirely new theory. Gilbert suggested that the Earth acted as a gigantic magnet, generating its own electrical field. He went on to demonstrate that material like glass and sulfur have electrostatic properties. He was the first person to use the term electric to describe these phenomena. His discoveries were made over 400 years ago, yet they are the basis for today's Volta batteries, electromagnets, and even the MRI scanners. Pierre van Mussenbroek was the 18th century. He was a skilled experimental physicist and a keen admirer of Newton. In 1746, he attempted to pass an electric current through a glass container. His bold experiment made him the first person in history to suffer electrocution. Mussenbroek's invention was known as the Leyden jar, was used throughout Europe. The device was an early form of an electric capacitor. Condensers are used today to store electrical charge. 1750, a letter reached the scientists of London's esteemed Royal Society. Benjamin Franklin posited the revolutionary hypothesis. What if lightning, the fire from the sky, was the same as the electricity observed in metals on Earth? The American was mocked by his peers, but 2 years later he proved his theory using a method pioneered by Jacques de Roman. Franklin used a kite fitted with a metal spoke to draw down electricity from the atmosphere. Soon he was to discover the principle behind his greatest invention, the lightning conductor. Coulomb was one of the greatest French scientists. In 1785, he became the first physicist to quantify the behavior of electricity. Coulomb gave a numerical expression to the power of static electricity. His laws enabled scientists to quantify, measure, and calculate electrical charges. Surprisingly, the international unit of electrical charge still bears his name today. Gauss is widely hailed as one of the greatest maths geniuses of all time. Produced remarkable work in a wide range of fields, from arithmetic, astronomy, and physics, and especially electricity, which is studied in the 1830s. Thanks to his studies of the Earth's magnetic field and the invention of the magnetometer, Gauss developed his law for electric fields. He gave his name to the unit for magnetic fields, a vital discovery that inspired Maxwell's research into electromagnetism. Galvani, 1780. He observed a strange phenomenon in his laboratory. The body of a dead frog moved at the touch of his scalpel. Galvani thought the scalpel had produced the reaction due to its electrical charge from a nearby electrostatic machine. Based on what he saw, he hypothesized the discovery of animal electricity. Galvani's interpretation was incorrect, but his accidental discovery led to today's Volta battery and a host of other modern inventions, including the Earth pacemaker. In 1791, Alessandro Volta responded to Galvani's work on animal electricity. Volta demonstrated that electricity is in fact generated by contacts between two metals. To prove it, he placed discs of zinc and copper on top of one another, separated by a piece of cloth. Volta's pile of metal discs became, quite simply, the world's first electric battery. In honor of his work, the unit of electric tension is known today as volt. In France, the word for battery is pile. 1840, Joule, a self-taught English physicist, discovered that electrical energy, when passed through a resistance conductor, dissipated heat. This is known as the Joule effect. Today, the Joule effect is the basis for simple electrical heaters used in homes all over the world. The concept of resistance. this guy. I have the revolution, industrial revolution up there, in contrast with the fields, the green fields to the right in the past, and the changes. And we're about to be in the middle. Arago was a brilliant physicist and an eloquent politician who entered the French Académie des Sciences in 1809 at 23. He was influenced and inspired by the discovery of Danish physicist Ørsted, the father of electromagnetism. In collaboration with his friend Ampère, he pierced its mysteries and perfected the electromagnet. Arago went on to make numerous other discoveries: how to magnetize iron, the diameters of our neighboring. In 1810, this genius and polymath was one of the first scientists to demonstrate the constant speed of light. That's Arago. Ørsted, his Danish, pursued a revolutionary vision in the scientific world to this day. He believed that magnetism, chemistry, and light were all connected with electricity in different ways. In 1820, he observed a strange phenomenon that confirmed his belief. By chance, he placed a wire bearing an electrical current near his compass and noticed that this caused the needle to move. He had proved that electricity could generate magnetic fields. This astonishing discovery may mark the beginning of the science of electromagnetism developed by Arago, Ampère, and Faraday. Where is Ørsted again? Arago here. In the early 19th century, French engineer Augustin Fresnel became interested in a topic that's part continuous. He sought to clarify the question and embarked on a series of optical experiments. He posited the light is a wave, and he proved this theory in 1918. He invented a type of lens based on concentric rings of glass, magnified and extended beams projected from lighthouses. So projector lamps used in filmmaking, lasers, and solar panels were all made possible by Fresnel's discovery. Ampère, 1820, a native of the city of Lyon and famed for his discovery of fluorine. In just a few weeks, he had invented a completely new field of science, electrodynamics. He developed a complete new theorem defining the terms of current and tension, and he even hypothesized that electrical currents were made by moving particles. These fundamental laws became the basis of a series of extraordinary inventions. The unit of intensity of an electric current, the amp, still bears his name today. Faraday was a self-taught research scientist fascinated by electricity and electromagnetism. Taking Ørsted's work as his starting point, he conducted his own experiments and discovered the principle of electromagnetic induction in 1831. Faraday showed that an electric current can be generated by moving magnetic field. Faraday's induction coil was taken up by others and used in numerous objects. Electric motors, captors in our telephones today. Gramme was a humble Belgian-born electrician when he created a revolutionary machine in 1869. Gramme's machine converted mechanical energy into electrical energy simply by turning a crank handle. The electric dynamo was born. In 1873, Gramme discovered that the phenomenon could be reversed. His machine would operate if it was connected to an electric current. This is the fundamental principle of all electric motors. Thanks to Gramme, electricity entered the industrial age. Look at that. That's the big change. That's the big guy. Dynamo back and forth. Marcel Dupré demonstrated electricity could be transported, and Goulart was astonished by the extraordinary technical feat. Goulart and his associate drew on the discovery to invent the electric transformer. The device worked with an alternating current, AC, and altered the voltage between the incoming current This made transporting electricity much easier and reduced energy loss. The pair demonstrated the device in Turin, where they delivered 8,000 volts of electricity. Transformers have since become indispensable for the transportation of electricity and in numerous fields. In the second half of the 19th century, Italian engineer Ferrari was inspired. He made an invention of direct current motor and Goulard and Gibbs transformers, which enabled the use of alternating current, AC. Ferrari was the first to unite the two. He invented the asynchronous machine, the first electric motor to use alternating current. The asynchronous machine is still omnipresent in everyday life today. Dupre trained as an engineer at France's École des Mines. He explored the use of very high voltage to transport electricity. In 1880, at the International Exposition of Electricity in Paris, he succeeded in supplying 27 electric devices over a distance of 2 kilometers. A few years later, Dupre transported over 70 kilowatts of electric power between Creil and the French capital. So he discovered the high voltage power lines that carry domestic electricity supplies to homes all over the world today. Scottish physicist, 19th century, developed a revolutionary hypothesis in 1873. He believed that light consisted of electromagnetic waves. For the first time, Maxwell devised a single set of basic equations that described electricity. This theory of electromagnetism completed and unified those of his predecessors, Ampere and Faraday. His discoveries continue to impact our life: radio, telephone, Wi-Fi, even lasers. Hertz, 1883. He began to study Maxwell's theory of electromagnetism. 2 years later, he achieved a remarkable technical feat in his laboratory. He succeeded in producing electromagnetic waves. So he made radioelectric waves that would eventually lead to the invention of radios. It had a huge impact in the 20th century. And of course, our unit of measurement for the frequency of radio waves bears his name today. Where is he again? Hertz, this guy. The only woman represented among the many scientists here. Curie was a brilliant scientist who conducted groundbreaking research on radioactivity. Marie and her French husband Pierre discovered that certain elements release energy as radiation. In 1898, the pair discovered two new radioactive elements, which they named polonium and radium. Marie Curie even succeeded in isolating pure radium and published a paper on her work. Marie Curie received 2 Nobel Prizes. She remains the only scientist to have won 2 prizes in different scientific fields. Today, husband and wife Pierre and Marie Curie are indissociable. In 1880, Pierre and his brother Jacques began their experimental work on the phenomenon of pyroelectricity. Pierre's meeting with Marie would change the course of his life. Together they discovered radioactivity. They also identified the element of radium and studied the effect of his radioactive properties. The discovery earned them the joint Nobel Prizes for Physics in 1903. Edison was a self-taught scientist and perhaps the best-known American scientist. Following his work to improve and perfect the telegraph, he invented the phonograph in 1877. So, the new mechanical device could be used to record and play music. Edison was an accomplished entrepreneur and businessman. Shortly after creating the phonograph, he took on the challenge of electric light. In 1879, he had a bright idea. Edison invented the incandescent light bulb and revolutionized modern lighting in the process. Over the course of his life, Edison registered 1,093 patents in his name. Where is he again? Here.